which is equal to En is equal to n square h cross square into pi square divided by 2m into a square. Okay, and we got the 0 point energy, which is not equal to 0. Classical physics said that 0 point energy is equal to 0, but quantum physics said that it is not equal to 0. After that, we the different energy levels E1, E2, E3 like this, and we have seen that the energy levels are not equal spaced. Have you written that? That means the energy levels are not equispaced. Okay. After that, we discuss the eigenfunction. Eigenfunction means to find out the unknown constant A. To find the unknown constant A, we have to take the normalization condition. Normalization condition, that is integration minus infinity to plus infinity psi x small square dx is equal to 1. We know psi x is equal to a sin kx whole square dx is equal to 1. After integration, we got the unknown constant a is equal to 2 by a under root. So this is the value of constant, and this constant a is known as normalization constant. As we have given the eigenfunction as psi n x, so what is your eigenfunction? The eigenfunction is equal to a sin kx, which is equal to this 2 by a under root sin kx. Okay. So after putting the value of k is equal to n pi by a, and this is your eigenfunction. Psi n x is equal to 2 by a sin n pi by a into x. Okay. So this psi n is called as normalized eigenfunction. This is known as normalized eigenfunction. Since we have taken the help of normalization condition, it is known as normalized eigenfunction. Okay. Okay. समझ में आया ना नहीं?
Yes, sir. Yes, sir.
Okay. So now, if you see for different since it depends upon n, you give the heading eigenfunction for different quantum states. Eigenfunction for different eigenfunction for different quantum states. Eigenfunction for different quantum states. Different quantum states means for n is equal to 1. What will be your psi 1x? Soumya? Are you there, Soumya? Soumya nahi. So who can say for n is equal to 1, what will be your equation 8? Psi 1 is equal to 2 by a sin
pi by a into x.
X. For n is equal to 2, psi 2 is equal to 2 by a sin 2 pi by a into x. For n is equal to 3, psi 3x is equal to
root 2 by
sin
3 pi by
into x. So these are different eigenfunctions. Eigenfunctions for different quantum states. Psi 1, psi 2, psi 3 are the different eigenfunctions. So if we plot graphically, the graph is like this.
clear vision.
Since we have taken, how negotiate kapat open kar di. Is it visible now?
No, sir.
No, sir.
कौन नो सर?
यस सर,
स्क्रीन शेयर करके कैमरा ऑन कर दीजिए, क्लियर होगा.
कैमरा ऑन नहीं है.
ये तो कैमरा ऑन नहीं हो रहा है. स्क्रीन शेयर हुआ क्या?
यस सर।
बट बैक कैमरा ऑन नहीं हो रहा है।
सर शेयर स्क्रीन करके आपके मोबाइल पे होम स्क्रीन पे जाना है और कैमरा ऑन करना है उसके बाद।
हाँ मैं तो किया है वही चीज। अच्छा एक बार हुआ देखो।
नो सर।
नो
नो
स्क्रीन
स्क्रीन।
शेयर
सर।
ऑफ हो गया है शायद।
स्क्रीन शेयर ऑफ हो गया है, स्क्रीन शेयर कीजिए पहले।
अभी आया देखो।
यस सर।
यस सर आया है।
यस
यस सर।
तो पूरा क्लियर आ रहा है क्या?
यस सर।
अच्छा
यस
ओके।
सर।
हाँ सर।
ओके सो ये ये हमारा क्या है, एक इन्फिनेटली डीप पोटेंशियल वेल ऑलरेडी हम बना दिए हैं। ये मिडिल पॉइंट है, ये x इज इक्वल टू 0, ये x इज इक्वल टू a विद द विड्थ, ठीक है ना। So, psi 1
सर पॉज हो गया स्क्रीन।
अभी देखो आया है। हेलो।
हाँ सर।
psi 2 ये है psi 3। ओके सो हियर n इज इक्वल टू 1, n is equal to 2, n is equal to 3, ये एक है। Okay, so this is a pictorial representation. Okay, so different quantum states means different energy levels. N is equal to 1, n is equal to 2, n is equal to 3, and this is the eigenfunction for first quantum states psi 1x, for second quantum states psi 2x, and this is the third quantum states. Okay, and this is hello. Hello.
यस सर।
यस सर।
यस
Is
सर।
it visible?
यस सर।
Huh?
यस सर।
Okay, so
Yes.
this is x is equal to a by 2. X is equal to a by 2, the middle point. Okay, so sometimes 2 mark question graphically represent what? Graphically represent the different eigenfunctions for different quantum states. 2 mark questions you have to do. Salla, diagram complete.
Yes,
This is
sir.
the
Yes, sir.
first quantum state, second quantum state, third quantum states, and so on. Okay, so it is not so important. Important चीज है हमारा probability. लिखो probability of finding the particle inside, probability of finding the particle inside a deep potential well. ये जो potential well में probability क्या होगा? हमारा काम यही है, we have to catch the particle. ओके, प्रोबेबिलिटी का फॉर्मूला क्या है? P इज इक्वल टू साई एक्स मॉड स्क्वायर। मैं तुमको बोले थे प्रोबेबिलिटी इज इक्वल टू स्क्वायर ऑफ द एम्पलीट्यूड, नहीं कि प्रोबेबिलिटी इज इक्वल टू स्क्वायर ऑफ द एम्पलीट्यूड,
यस सर।
प्रोबेबिलिटी इज इक्वल टू स्क्वायर ऑफ द वेव फंक्शन. So P is equal to psi x mod square. Since we have a different quantum states, we can put psi n. Okay, understood? So this gives you, if you take the square, so directly I am writing 2 by, hello,
Yes, sir.
2 by A, 2 by A, hello, is it visible, Pragya?
Yes.
Yes, sir.
Yes, sir.
Clearly visible?
Yes, yes, sir.
Not so
एक
clear,
मिनट,
sir.
Sir,
अभी
के
डॉट
blur আসছে।
Network.
2 by A, 2 by A sin square, देखा लिखो 2 by A, if you take, we know sin psi n, if you take the square 2 by A कितने लिखी हुई sin square
Sin kx, sin square kx.
n pi by A into x. So this is the formula for probability. Okay, so this is the formula for probability. So Pn is equal to 2 by A sin square n pi by A into x. Okay, now if you write, now you write, एक minute, now you can find the different, probabilities. P1 for n is equal to 1, कौन हबो? For n is equal to 1, how
2 by
much?
A sin square pi by A into x.
P1 is equal to 2 by A sin square
Sin square pi by A into x.
pi by A into x. For n is equal to 2, P2 is equal to
2 by
2
A
by
sin
A
square 2 pi by A into
sin
x.
square 2 pi by A into x. For n is equal to 3, P3 is equal to
P3 2A sin square
2 by
3
A
pi by A
sin square 3 pi by A
3 pi by A x.
into x. So on. So these are the different probabilities. So how can we represent graphically? Same diagram plot karo. You see the difference between probability and the eigenfunction. This is x is equal to 0, x is equal to a. This is the first probability, P1. Next is second probability, like this, P2. And this is the third probability. Third probability means 1, 2, 3. Very important diagram. Remember, n is equal to 3, n is equal to 2, n is equal to 1. This is x is equal to a by 2. Very, very important. Remember. Okay. The pictorial representation of, the graphical representation of probability. Okay. Complete diagram complete.
Sir, P3 ସେଇଟା
Yes, sir.
हाँ, এটা P3.
P1 P2 P3
Different probabilities. Okay. Sallah.
Yes, sir.
yes
Sir.
sir.
Okay. So I have written probability of finding the particle inside the deep potential well. Now suppose Pragya has entered into the deep well to catch the frog. So one frog is staying inside the well. Pragya has entered to catch the frog. So what will happen? So what is the probability of finding the frog? So when the frog sees to Pragya, the frog jumps from one position to this position because frog wants to hide Okay, so the frog will jump a single jump. Again, when Pragya entered deep portion of the well, the frog will make one jump. This is the second jump. Again, if Pragya entered more and more deep into the well, the frog make a three jump, one jump, two jump, and three jump. So these are the probability, different probabilities for finding the particle inside the deep potential well. समझ में आया?
Yes, sir.
Yes, sir.
Okay. So here the probability are different or same? Probability is same or different?
Different, sir.
Different, sir.
Different. So this is 1, this is 2, this is 3. So the probability of finding the particle is different at a different position. But your classical physics said that it is same. Okay. So right. Thus, the probability of finding the particle, the probability of finding the particle is different at different position.
Sir,
Thus, the probability of finding the particle is different at a different position. It is, that means it is not uniform. That means it is not uniform. That means it is not uniform, and it depends upon the quantum states. It depends upon the quantum states. Okay, it depends upon the quantum states. Okay, this contradicts the expectation of classical physics. This contradicts the expectation of classical physics, according to which this contradicts the expectation of classical physics, according to which the probability of finding the particle is uniform. Probability of finding the particle is uniform. Okay. Probability of finding the particle is uniform because,
Yes, sir.
okay, Mona Lisa, Sonila Malik, nobody is there. Tejas Singh,
Yes, sir.
तेजस रीड करो क्या लिखे हैं लास्ट स्टेटमेंट.
Thus, the probability of finding the particle is different at a different position. It is not uniform and it depends upon the quantum state. This contradicts expectation of classical physics, according to which the probability of finding the particle is uniform.
ओके, थोड़ा सा एक्सप्लेन करो क्या है उसका मीनिंग. तेजस,
सर ये जो प्रोबेबिलिटी है स्टेट पे डिफरेंट होगा।
ओके, वेरी गुड। नेक्स्ट, ये सुनो, एक बार ध्यान से सुनाई करो। ये जो प्रोबेबिलिटी का डायग्राम हम दिखा है ना, प्रोबेबिलिटी का डायग्राम और जो फॉर्मूला है, ठीक है, पी एन इज इक्वल टू 2/a साइन स्क्वायर n पाई बाई a into x. So we are getting p1, p2, p3. So here the probability is not same, different. Here 1, here 2, here 3, next 4, like this. So probability of finding the particle is different for different quantum states. But your classical physics said that probability is uniform. That means constant. So there is a contradiction between classical physics and quantum physics. समझ में आया?
यस सर।
Yes,
Yes,
sir.
sir.
Okay. So
Yes, sir.
ये जो क्वेश्चन एक लॉन्ग क्वेश्चन है, ये लॉन्ग क्वेश्चन इज दैट मीन्स ये जो तुम्हारा क्या है, पार्टिकल इज एनक्लोज्ड इन एन इन्फिनिटली डीप पोटेंशियल वेल. द क्वेश्चन इज solve time independent Schrodinger equation for a particle enclosed in an infinitely deep potential well. Okay, उसके बाद find the energy eigenvalue and eigen function of the particle. So ये चीज पूरा तुमको करना ही होगा. You have to set up the differential equation, time independent Schrodinger equation. You have to find the solution. Next, we have to use the boundary condition. Using the first boundary condition b is equal to 0. उसके बाद हम क्या करेंगे? उसके बाद सेकेंड बाउंड्री कंडीशन को अप्लाई करेंगे. करने के बाद we shall find the energy eigen value. एनर्जी आइजन वैल्यू को करने के बाद आफ्टर गेटिंग द एनर्जी आइजन वैल्यू, ये जो डेल ई का कोई जरूरत नहीं, डायरेक्टली यू गो टू आइजन फंक्शन. You have to integrate. Suppose you have forgotten the integration, but you have to remember that a is equal to 2/a under root. ये करने के बाद you can write the different eigen function and different probabilities. ठीक है ना? ये शायद 3 पेज हो जाएगा, मैक्सिमम 3 पेजेस. ओके, ये एक बड़ा लंग क्वेश्चन, आइदर 10 मार्क का आएगा और उसके साथ 7 और 8 मार्क उसके साथ एक न्यूमेरिकल. ठीक है ना? समझ में आया? ये पूरा डिटेल्स, एनर्जी आइजन वैल्यू, आइजन फंक्शन यू हैव टू डू. ठीक है? समझ में आया?
Yes, sir.
Yes, sir.
ओके, अच्छा. सो ये तो हमारा सब क्वेश्चन अभी ये हो गया क्वांटम फिजिक्स का. ये जो आज जो क्वेश्चन तुमको हम दिए थे, एक्सपेक्टेशन वैल्यू, हो गया सबका? हो गया परिचय? क्वेश्चन था जो द पार्टिकल इज ट्रैप्ड इन वन डायमेंशनल बॉक्स ऑफ लेंथ 1 सेंटीमीटर. फाइंड द एक्सपेक्टेशन वैल्यू ऑफ पार्टिकल्स पोजीशन. क्या होगा बताओ परिचय? सौम्य, अरे ये क्वेश्चन था ना? नहीं, आज जो सरप्राइज टेस्ट का क्वेश्चन था ना? नहीं, the particle is trapped in one dimensional box of length 1 centimeter. Hello, nobody is asking. Hello, am I audible?
Yes, sir.
सर
क्या करेंगे बताओ? सब सो गए पूरा. फाइंड द एक्सपेक्टेशन वैल्यू ऑफ पार्टिकल्स पोजीशन. क्या होगा बताओ, जल्दी बताओ. ये 4 ऑप्शन था, कोई भी एक ऑप्शन को तुम क्लिक कर दिए. नहीं, anybody who can say what is the particles, what is the expectation value of particles position? अरे, may be wrong or right, you open your mouth.
1/3, sir.
हाँ,
1/3.
1/3. बताओ ना कैसा हुआ, बताओ आंसर. फाइंड द एक्सपेक्टेशन वैल्यू ऑफ पार्टिकल्स पोजीशन. सो यहाँ पे फिजिकल क्वांटिटी कौन है? पोजीशन. Position means I have to write x. This is the
X.
symbol of the expectation value. Okay. So this is x expectation value integration. क्या होगा? psi star
माइनस इनफिनिटी
x cap psi into dx. यहाँ पे तुमको दिया है लिमिट इज गिवन. The particle is trapped in one dimensional box of length 1 centimeter. Length 1 centimeter means 0 to 1. Okay. Acha, what is the wave function? Wave function is given here. What is the wave function is given?
Psi equal to X.
Psi is equal to x. Okay. If psi is equal to x, what is the psi star? कोई इमेजिनरी पार्ट है क्या यहाँ पे?
नो सर.
नहीं है. सो ये रिमेन सेम. साई स्टार का वैल्यू x हो जाएगा. ये x ऑपरेटर का वैल्यू कितना है? व्हाट इज द ऑपरेटर वैल्यू ऑफ x कैप? अरे हे, ऑल आर donkeys. What is the expectation value of x cap? Who can say?
Sir, X.
x cap x होगा. यहाँ पे साई के जगह में क्या लिखेंगे? साई x लिखेंगे. इंटीग्रेशन x x x क्या हो जाएगा? x क्यू. x क्यू का इंटीग्रेशन क्या हो जाएगा? x to the power 4 by 4. Limit is 0 to 1. Okay. After putting, what is your answer? 1 by 4. समझ में आया? What is your answer now? The expectation value of particles position is how much?
1 by 4
1 by 4. Have you done answer 1 by 4? अरे तुम्हारा आंसर 1 by 4 आया ना? नहीं. अरे
Sir, आया.
nobody is giving the answer. प्रज्ञा,
Yes, sir.
तुम्ही अरे तुम्हारा आंसर कितना असला? What is the total probability? I told you. What is the total probability? Huh? What is total probability of a system? अरे के भी जने आंसर करो. 1. Total probability is equal to 1. So I told you probability is equal to square of the amplitude. Probability is equal to psi x mod square. If the limiting values are given, the probability is integration that limiting value psi x mod square dx or dv you can take. Okay. Okay. So this is all about, and already I told you energy expectation value P1 E1 P2 E2 plus P3 E3. Okay. E1 E2 E3 are the energy eigenvalues. P1 P2 P3 are the probabilities. बुझिएला?
Yes.
Okay. So this is अच्छा, serial number 1. You open your copy. Serial
Yes,
number
sir.
1. Open your copy. I want to check. अभी कुछ time बचा है. So this is all about our module 5. I have completed module 5. Okay. अच्छा, module 1 कहाँ पे हुआ था मैडम? कहाँ तक लिए थे तुम्हारा कोर्स को? module 1 oscillations complete ना? Don't waste the time.
Yes, sir.
हम क्या करेंगे? स्क्रीन शेयर को स्टॉप करना होगा ना?
यस सर, आप बंद कर दीजिए.
अच्छा, बंद फिर कैसा होगा? हाँ, अभी हो गया. मेरा फेस क्यों आ गया? कहाँ पे है रे?
सर आपका स्क्रीन शेयर था ही नहीं.
वो तो टाइम चला जाएगा, क्या बचेगा फिर? देखो, ये तो रो 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 शुरू से दिखाओ, इलेक्ट्रोमैग्नेटिज्म से दिखाओ, इलेक्ट्रोमैग्नेटिज्म से दिखाओ थोड़ा सा।
सर E2
इलेक्ट्रोमैग्नेटिज्म काई हेडिंग काई, इलेक्ट्रोमैग्नेटिज्म हेडिंग काई
सर इट देइछि इलेक्ट्रोमैग्नेटिज्म
काई मते देखा जाउनी, तमु देखा जाउजी। खाली ब्लर होଉଛି, କିଛି ଦେଖା ଯାଉନି, ସେ ଏଲୋଟା ଦେଖା ଯାଉଛି, କିଛି ଗୋଟେ ବି ଲେଟର ଦେଖା ଯାଉନି ରେ ବାବୁ ଅଭିନନ୍ଦନ।
सर
ଗୋଟେ କନଷ୍ଟାଣ୍ଟ ରଖ, ଗୋଟେ ଜାଗାରେ ମୋବାଇଲ ଟାକୁ ରଖ, ଗୋଟେ ଜାଗାରେ ରଖ ଏବେ।
देखा जाଉଛି ସାର୍ ଆମକୁ।
ଦେଖାଯାଉଛି
सर
ସାର୍।
विजिबल होछि
ହଁ ତମକୁ ଦେଖା ହବନି କି, ମତେ କେମିତି ଯେ ହଁ ଏବେ ରାଇତ ହଁ ओके ठीक ଅଛି, चलो पेज पेज टर्न करो, पेज टर्न करो। ठीक ଅଛି, ओके गुड नेक्स्ट। वेट कौन, हाँ डेल डॉट डी इज इक्वल टू रो, नेक्स्ट चल जल्दी जल्दी चल। एडी कौन छाड़चो
सर कोठी
मुझे जूम कर, हाँ ठीक है चल चल। तापर इक्वेशन ऑफ कंटिन्यूटी आसला, ठीक अच्छे नेक्स्ट। हम्म एन तक जीव है